All right. Section 852, how can I simplify complex fractions? We actually learned about complex numbers back in chapter 4. So this isn't like with I. You'll see what we mean with complex fractions in just a second. So our warm-up is to add those rational expressions and write the answer in simplest form. So here, I've got 3 over x plus 3, which is great because that doesn't require any factoring. But the right-hand denominator is a little annoying because I have 2x squared plus x minus 15, and that 2 is not a GCF. So I have to do my a times c method, which means I need numbers that multiply negative 30 because that's 2 times negative 15, but adds up to 1. Those are 6 and negative 5, which means I now take the plus x that I had and replace it with plus 6x minus 5x, and then keep the minus 15 the same. So again, all I did was replace that one term with those two terms, and now we can factor this. I've got 2x times x plus 3 over here, and negative 5 times x plus 3 over here, which is awesome. So that this thing factors into 2x minus 5 times x plus 3. So that is my new denominator, 2x minus 5 times x plus 3. So now all this, like this work is great, but not necessary. It's like a little side calculation. Now I see that my left-hand fraction is missing the 2x minus 5. So I need to multiply that on top and bottom, 2x minus 5. I'm going to go ahead and distribute the 3 through the top. So I get 6x minus 15 over 2x minus 5 times x plus 3. And then plus x minus 9, 2x minus 5, and x plus 3. This is an addition problem, so I'm just going to combine like terms on top. I see I have 6x plus 1x, so there's 7x. Whoops. That's 7x. Negative 15 plus negative 9 is negative 24. That does not have a GCF, so 2x minus 5 times x plus 3. With a domain restriction of x cannot be negative 3. And then this second one, the 2x minus 5, if you want, you can go a little side calculation here and see what makes it equal 0. Add 5 to both sides, divide by 2, and that would be 5 halves, or 2.5, which means that is the other number that x cannot be, 5 over 2. Let's do the whole thing. But again, this is fully simplified because 7x and 24 have nothing in common. Okay. So that was day 1 of 852. This is what we mean by a complex fraction. It means that there are fractions in the top and there are fractions in the bottom as well. So to solve this, what I'm going to do for now is kind of ignore the bottom. I'm going to pretend like it's not there, and I'm just going to worry about adding those top fractions together. I have denominators of x and y, so that means I need to multiply the first one by x on top and bottom, and the second, well, to multiply the second equation, the second fraction by x, the first fraction needs y, so then this becomes y over xy plus x squared over xy. So now I have a common denominator. I'm going to add the tops, but y and x squared aren't like terms. I can't actually add them. So I'm just going to keep it y plus x squared over xy. So there's my, I shouldn't box that in, but this is first half of the problem. This is top fraction. Hooray. And now we're going to go ahead and take a look at the bottom. And again, kind of imagine that this is just the problem we have to solve. This is the first time that we've done this one where it's a fraction plus a number. the easiest way to do this is just to write the whole number as a fraction. So 1 over 1, which means then I need a y in top and bottom. Technically, you could multiply by 1 on top and bottom for the first fraction. Totally unnecessary since multiplying something by 1 doesn't actually change it. So we end up with 1 over y plus y over y. Now I can add those numerators to get 1 plus y over y. And I'm actually going to, I don't love the look of that. You could leave it like that, but I'm going to rewrite as y plus 1 over y. Okay, so I've got the numerator solved or simplified. I've got the denominator solved or simplified. And now if you think about it, this line right here, right, that's the division symbol, that's the fraction bar. That just means I'm taking the top fraction and I'm dividing by the bottom fraction. Okay, so top fraction divided by bottom. If you want, you can rewrite it like that as y plus x squared over xy divided by y plus 1 over y. But again, that's a little silly because we know that when dividing fractions, I'm going to go ahead and flip and multiply. I'm going to flip that second fraction on itself. But we do have to take a pit stop here real quick to talk about what the domain is. I see that the denominators are all just variables with no plus or minus. So x can't be 0 and y can't be 0. Again, I'm going to come back to this list in a little bit. So when I take that second fraction and flip it, what this becomes is y plus x squared over xy multiplied by y over y plus 1. So now because I'm flipping it, since we just talked domain, that new denominator is actually going to add -1 to the list of values that y cannot be. And now all I'm going to do is see if I can cancel anything. Going back to 8.4, this does not cancel that because both of those y's have some number being added to it. Now, this y on the bottom left-hand corner, that's just x times y, so I am free to cancel out either one of those x's or either one of those variables, x or y, if there's another loose variable on the top or the bottom. So this y on top with no plus or minus can cancel that y on bottom with no plus or minus. So what I end up with is y plus x squared, that's my entire numerator, over, on the bottom I have the x from the left, and I have the y plus 1 from the right. This is then my final answer. So when we're doing these complex fractions, simplify the top, simplify the bottom, then we're going to talk about domain and flip the bottom fraction up to make it a multiplication problem. Oh, good Lord. Okay, only a couple more. This is about as nasty as it gets. So I'm going to go ahead and, again, ignore the bottom here. I can't say it enough, okay? If I'm trying to get a common denominator here, you can't just do this. You cannot simply add 1 to both sides of a fraction because then you are changing the value. I have to use multiplication here, which means that I need to, in order for them to be a common denominator, this left-hand fraction needs x plus 1 multiplied on the top and the bottom. And this right-hand fraction needs x multiplied on top and bottom. And what that allows me to do now is I have a common denominator between those two fractions. So I'm going to go ahead and multiply the numerators together. If I'm foiling this out right now, that ends up being x squared minus x minus 2. And then I have plus 2x from this fraction right here, the second fraction. And that's all over my denominator of x times x plus 1. Okay, I'm going to go ahead and combine like terms there. This becomes x squared plus x when I combine -1 with +2, minus 2 over x times x plus 1. And then actually that new numerator does factor. I can find numbers that multiply to -2 but add to +1. And so in one final step here, I have x plus 2 times x minus 1 all over x times x minus 1. Okay, so all that for the first half of the problem seems like a lot because it is. And you might say to yourself, like, oh, hey, I see x minus 1, that's going to cancel. And we will cancel it, but I want to talk, we want to make sure that we talk domain restrictions first before we get to that. So let's tackle this bottom problem. Again, x minus 1 and x plus 1, like, even though they look very similar, like mathematically, they are nothing alike. So I need to multiply the first fraction by x plus 1, and the second fraction needs x minus 1. You'll also notice that, just to throw you another curveball, this is a subtraction problem. So if I multiply the tops together, if I distribute the 3, I get 3x plus 3. And if I distribute the 1, I have x minus 1. And I put that in parentheses for a reason, so that I remember to distribute the minus sign to both the top and the bottom. So here, if I distribute that minus sign to that and that, I end up with 3x plus 3 minus x and then plus 1. X plus 1, x minus 1. So then 3x minus 1x, that is 2x. 3 and 1 make 4, or x plus 1 times x minus 1. And then the numerator does have a GCF of 2. So I'm going to go ahead and do that. Take out the 2, x plus 2, over x plus 1 and x minus 1. So all that work, all that nonsense, there's my top half and there's my bottom half of the fraction. So now we're going to put them side by side and talk domain and cancel some stuff. So we got x plus 2 times x minus 1 over x times x minus 1 divided by 2 times x plus 2 over x plus 1 times x minus 1. So again, the nice thing is we only have the variable x to worry about. So x currently cannot be 0 because of that. X cannot be positive 1 because of these. And then x also cannot be negative 1 because of that. Okay. And we will add to this list in just a second. So I'm going to go ahead and flip the second fraction. So x plus 2 times x minus 1. Isn't it fun to just watch someone else write on an iPad? Times x plus 1 times x minus 1 over 2 times x plus 2, which now adds to my domain. I see that now I have an x plus 2 in the bottom. So that means joining the list of numbers that x cannot be is -2 because of that. So now our last step is just to cancel. So now again, like this x minus 1s from earlier, those do cancel each other out. And that's actually, no, x plus 2 cancels x plus 2. So then I end up with x plus 1 times x minus 1 on top, all over, all I have left is this x and that 2. This is all multiplication, so 2x. There's my end result. Hooray! So, kind of a lengthy process. Again, you're treating it as two separate problems and then rewriting it as a division problem, which we then flip and multiply as a multiplication problem. But just take it piece by piece. It takes a little bit of time, but we're getting down to the nitty-gritty of the end of this course. So I got to get to some of the difficult stuff. If you want, go ahead and pause it, try these two problems out, and then we'll wrap this up. 14 minutes so far. Let's get this down under 20. Nice thing about this fraction, the numerator isn't a fraction, it is just x. So that's the top part's done. Here on the bottom, I see x and I see y, so xy is going to be my common denominator. So then what happens here is I end up with y over xy plus x over xy. So that means that I have x over 1, and that is this. You didn't need to put over 1, but whatever. Divided by y plus x over xy. Okay, that is my bottom fraction. This was here. This problem is actually kind of difficult because when we talk domain, you actually won't be asked to do domain if it's multiple variables just yet. But for now, I can say that x can't be 0 and y can't be 0. I'm going to go ahead and then flip the second equation, or flip the second fraction. And you'll notice that I also reordered x plus y instead of y plus x. Doesn't really matter. What does matter here is that this does not cancel. I cannot cancel that x and that x. Reason being, that bottom, the denominator isn't just x, it is x plus y. And this is what I was saying about the domain can be a little tricky. Don't worry about this. Technically, there's another stipulation you'd have to make, but we're going to leave it. So when I'm multiplying, I see x multiplied by x, so that's going to give me x squared times y in the numerator. And then in the denominator, I have just x plus y times 1, which isn't necessary. Okay, so that's that first U try. I'm going to go ahead and take this, shrink that down a little bit. And now this final one, again, kind of treating you nice. The top fraction is already, it's not an addition or subtraction problem. It is just, here's this fraction. But on the bottom, I have 1 over 1, which means in order to get a common denominator, I need to multiply the left side by x minus 4. So I'm going to distribute 1 there. So I got x minus 4 over x minus 4. And this is a minus problem, which is a little tricksy. It's not as bad because the second numerator is just one number. So all I have to do is remember to subtract 2. So when I combine that, x minus 4 minus 2 is x minus 6 over x minus 4. So here is top fraction, and here is bottom fraction. So I'm going to go ahead and set these as a division problem. So 3 over x minus 4 divided by x minus 6 over x minus 4. Common denominator, don't need to be common denominator for division. But here right now, x cannot equal positive 4. Or when I flip the second fraction, because it's division, x cannot be positive 6. 1 minute left. Here, of course, I didn't put parentheses around all these, but the x minus 4s do cancel. So I end up with a expression that's just 3 over x minus 6. Bam. So that is complex fractions. Treat the top and the bottom individually, simplify them, and then write it as a division problem. Flip the second one and multiply. Homework 21 to 29 and 41, only the odd problems. So it only ends up being like 6 problems total. Will take you a little bit of time, but you'll be all right. So until then, I need to think of some sweet sign-off phrase.